Hello everyone. In this video we are going to discuss about conformal mapping and the mapping W is equal to Z square. First we can see the definition of conformal mapping. The mapping that preserves angle in magnitude and direction is called conformal mapping. That is, if you have two curves C1 and C2 and if they are intersecting at Z0 and the angle between the C1 and C2 at Z0 is alpha, and under the mapping F, suppose C1 star and C2 star are the images of these curves C1 and C2, and corresponding to Z0 we will have a point f of Z0 here. Then this angle, the angle between C1 star and C2 star at the point f of Z0, it is also equal to alpha and in the same direction. First we can see the conformal mapping of the function W is equal to Z square. If you take the polar form, suppose Z is R e raised to I theta and W equal to capital R e raised to I phi. Then under the mapping W equal to Z square, we can say that R e raised to I phi is equal to Z square. Z is R e raised to I theta, the square, which is equal to R square e raised to 2 theta. So here if you compare the magnitude and direction, you can see that R is equal to R square and the argument phi is equal to 2 theta. So a circle with a radius R equal to some R naught will be mapped onto another circle with a radius capital R is equal to R naught square. And if you have a ray with a angle theta equal to some theta naught, it will be mapped onto another ray with angle phi is equal to 2 times theta naught. For example, consider the region 1 less than or equal to mod z less than or equal to 3 by 2, pi by 6 less than or equal to theta less than or equal to pi by 3 under the mapping W equal to Z square. So if you consider, first you consider this part. First you can see that mod z equal to 1 is a circle with radius 1 and which will be mapped to mod omega equal to R square. Here radius is 1, so 1 square which is equal to 1. Now the other part, mod z less than or equal to 3 by 2. So if you take mod z equal to 3 by 2, which is mapped to mod omega W is equal to 3 by 2 square, which is equal to 9 by 4. Now if you consider this region, pi by 6 less than or equal to theta less than or equal to pi by 3, theta equal to pi by 6. As we know, theta equal to theta naught will be mapped to phi equal to 2 times theta naught. So theta equal to pi by 6 is mapped to phi equal to 2 times pi by 6. That means pi by 3, and theta equal to pi by 3 will be mapped to phi equal to 2 times pi by 3. So you can see that this region 1 less than or equal to mod z less than or equal to 3 by 2, pi by 6 less than or equal to theta less than or equal to pi by 3 is mapped onto the region bounded by 1 less than or equal to W less than or equal to 9 by 4. So the region 1 less than or equal to mod z less than or equal to 3 by 2, pi by 6 less than or equal to theta less than or equal to pi by 3 is mapped to 1 less than or equal to W less than or equal to 9 by 4. And pi by 3 less than or equal to 5 less than or equal to 2 pi by 3. You can represent this mapping as shown in this figure. You can see that this is mod z equal to 1 and this circle is mod z is equal to 3 by 2, and this ray represent theta equal to pi by 6 and this ray represent theta equal to pi by 3. So this will be the given region 1 less than or equal to mod z less than or equal to 3 by 2 and pi by 6 less than or equal to theta less than or equal to pi by 3. So this region is mapped to this region. Here you can see that this circle is mod W is equal to 1 and the outer circle is mod W equal to 9 by 4, and which is the rays are mapped to phi equal to pi by 3 and phi equal to 2 pi by 3. So this will be the region. So you can see that this region is mapped to this region under the mapping W equal to Z square. Now we can discuss the Cartesian representation of the mapping W is equal to Z square. So we can take the Cartesian form of Z is equal to X plus IY and W is equal to U plus IV. So under the mapping W is equal to Z square, you can write W is U plus IV, which is equal to X plus IY the square. So which is equal to X square minus Y square plus I into 2XY. So you can see that here U is equal to the real part, it is X square minus Y square and V equal to 2XY. From this U and V, we can eliminate X and Y and find the image of the given function. For example, if we want to find the image of the vertical line X equal to C, first we have to find the value of U and V. Here we know U is X square minus Y square and V equal to 2XY. So you can write U is equal to, here we want to find the image of X equal to C. So substitute X as C here. So C square minus Y square and the value of V is 2CY. Now from this you can find out the value of Y as Y is equal to V by 2C, and this value of Y you can substitute in this equation to find the value of U. In this you can see that U is equal to C square minus Y square. Y square is V by 2C the whole square. From this we can write as V square by 4C square is equal to C square minus U. So you can say V square is equal to 4C square into C square minus U, which you can write as minus of 4C square into U minus C square. We already know that Y square is equal to 4AX and Y square is equal to minus 4AX are the equations of parabola. So this V square is equal to minus 4C square into U minus C square represents a parabola. So you can say that X equal to C, the line X equal to C is mapped onto a parabola. V square is equal to minus 4C square into U minus C square. So you can see that the line X equal to 1 which is mapped onto a parabola which is open towards the left. Now we can see one question. Find the image of the triangle bounded by the lines X equal to 1, Y equal to 1 and X plus Y equal to 1 under the mapping W equal to Z square. So here under the mapping W equal to Z square, we can write W as U plus IV equal to Z is X plus IY the square, which is equal to X square minus Y square plus I into 2XY. So U is equal to X square minus Y square and V equal to 2XY. So first we can find the image of the line X equal to 1. So when X equal, give this as equation number 1 and 2. So for X equal to 1, by 1 U will become 1 minus Y square and V is equal to 2 into Y. From here you can write Y as V by 2. So this will become U equal to 1 minus V by 2 the square, which is equal to V square by 4 is equal to 1 minus U. Or you can see that V square is equal to minus 4 into U minus 1. So we already see that V square equal to minus 4AX, which is a parabola open to the left. So V square is equal to minus 4 into U minus 1 is also a parabola. So you can see that X equal to 1 is mapped to this parabola. For Y equal to 1, we can apply the same method. So U equal to X square minus 1 square and V equal to 2X. So from here X equal to V by 2. So you can see that u is equal to v by 2 the square minus 1, which implies v square by 4 is equal to u plus 1. This implies v square is equal to 4 into u plus 1, which also represents a parabola. So the straight line y equal to 1, the image of y equal to 1 will be a parabola open towards right. V square is equal to 4 into u plus 1. Find the image of the line x plus y equal to 1. We have our u is equal to x square minus y square. This can be written as x plus y into x minus y, and here we have x plus y is 1. So this u will become 1 into x minus y, which is equal to x minus y, and our v is 2xy. Now we have to eliminate x and y from these equations. We can use this formula. You already know this. X plus y the whole square is equal to x minus y the whole square plus 4xy. You already learned this formula in algebra. So x plus y whole square is equal to x minus y the whole square plus 4xy. So here we already know x minus y as u and x plus y is 1. So 1 square is equal to x minus y is u square plus 2xy is v. So 4xy will become 2v. So you can see this u square is equal to 1 minus 2v. This also represents a parabola. U square is equal to minus 2v plus 1. So our required region, the image of the line x equal to 1, y equal to 1 and x plus y equal to 1 is the region bounded between the three parabolas. The parabolas are v square is equal to minus 4 into u minus 1, then v square is equal to 4 into u plus 1, and the last parabola u square is equal to minus 2v plus 1.